Okay. Good morning, Akshita. We are going to discuss yesterday one problem which is left out from trigonometry, that is 12th question, and some 8th and 9th are given to you as homework. Even I think 10th is given to you as homework. No. 10th and 11th we have done yesterday. Now 12th is the only question left out. 8th and 9th are your homework. I'm copying this now. Let's paste it here. Yeah, it's recording properly. Now, I also opened the PDF of surface area and volume. Many things are given in this surface areas and volume. I think I'll be taking it from a different textbook, because this textbook anyhow they are going to teach in your school. I will take it from different textbook. Let's see this 12th question. Two ships leave from the same port. One ship travels on a bearing of 157 degrees at 20 knots. I think 1 knot is 1 nautical mile per hour. They are only giving, even I don't know. So 20 nautical miles per hour. The second ship travels on a bearing of 247 degrees at 35 knots. How far apart are the ships? How far apart are the ships after 8 hours to the nearest nautical mile? Okay, we have to take the soft record structure. Okay, so many instruments are given, many things are given. Okay, fine. Let's first draw the coordinate axis. If you see, from this is the starting point of both the ships. One ship is going at 157 degrees, matlab 90 plus 67. So it is going at some angle like this. Let's imagine this is the point where ship A is there after after 8 hours. Next one, 247 degrees. 247 will be 180 plus 67, right? So actually the one thing here, this angle is going to be 67 degrees and this is going to be 90. So total 157. Now next one, 247, somewhere here. Yeah, somewhere here, we don't know. Is it 90? We have to see. So this is where the ship be, and if you see carefully, they told it's a 247, 180 plus 67. Therefore, this angle is 67. And now, if you see carefully, this angle will become 90 minus 67. That is 23 degrees. Therefore, when you add 67 and 23, this is going to be exactly 90 degrees, right? So this is one of the advantage of the information given in the question, that it is 90 degrees. We can use Pythagoras theorem. Now main thing is, let's call this point as O. We need to find out what is OA distance and OB distance. OA distance will be, sir, you might have learned in the physics. Okay, let's forget the physics. 20 knots is the speed of the ship A. 20 nautical miles in 1 hour. So in 8 hours, how many nautical miles it will travel? 20 in 1 hour. In 8 hours, it is going to be 160 nautical miles. So that's nothing but 20 into 8. Similarly, the second ship is traveling at 35 knots. Means 35 nautical miles per hour. In 8 hours, how much it will travel? 8 into 35, which is going to be 240 plus 40, 280 nautical miles. This much distance. So OA length is going to be 160 nautical miles. OB length is going to be 280 nautical miles. Okay. Now Akshita, after knowing this, Okay, first please note down the diagram. I'll give you, um, some 1 minute of time. Please note down. Okay, I think 1 minute is over. I'm finding R.D. Sharma textbook to teach you this volumes, surface areas and volumes of the solids. You'll get a solid knowledge about this one. So after that, anyhow from the school you will hear this chapter again from your teachers. And my plan is, after covering R.D. Sharma, anything is left out from your textbook, that also I'll cover it up. So it'll like overall knowledge for you. Now we need to find AB distance. So if you see carefully here, AB will become the hypotenuse. AB becomes hypotenuse. See that right angle triangle? Therefore, according to Pythagoras theorem, OA square plus OB square is equal to AB square. Therefore, AB square will become 160 square plus 280 square, and AB will become square root of 160 whole square plus 280 whole square. Now Akshita, what you can do with your calculator and write down the answer in the nearest nautical mile. You have to approximate, no decimal place, and check the answer whether you got the same or not. Okay. Now, okay, please do this question. I'm going ahead to do the next one, very important part, next one, sir. See here, I think we don't even need this line. Cut it off. Now the second question what they're asking is bearing of second ship, that is B, from the first. So you should take the A as center and you need the bearing of B. It's not so easy. Okay, so let's first calculate this answer. I think I have to calculate it. No other option for this. I'll bring my calculator. Without knowing this, we can't calculate the bearing. Root of 160 square root of 160 square plus 280 square. Okay, it's not going. I don't know how to calculate this. 1 second. Square root of 160 square uh, 160 square plus 280 square. I'm getting it as 322.49. If I approximate this, the answer should be 322 nautical miles. So answer is AB distance. The first one they are asking, how far apart are the ships after 8 hours to the nearest nautical mile? Answer should be 322. Now let's take it till here. Now what we need is, with the A as center, we need the bearing of B. This is a very important question. Very important question, Akshita. We need, with the A as center, we need the bearing of B. How do we really calculate that? Okay, we can just join AB again, which we removed it. We wanted to know. So let's put it with the solid line. Okay, then this length is 322. Okay, Akshita, let's find out this small angle. Let's call it theta. Question is little critical. If at all any doubt, please ask me. The same question, if you're feeling doubtful in the class, I will explain live to you the next Saturday. But right now, if you can understand it, it's done. Now we need to find the small theta. One more thing, this angle is surely 90 degrees, right? So this is going to be 23 degrees. Itna to clear, 23. Now we need to find theta. For that I am going to use tan theta. Tan theta is the opposite side 280 by adjacent side 160. So you will be getting 28 by 16. If you cancel, 2 14s, 2 8s. Still you can cancel 2 7s, 2 4s. So you will be getting 7 by 4. So now theta will become tan inverse of 7 by 4. I'm calculating that. I'm getting almost 60 point. Did he ask us to say nearest minute, right? Yeah, I got it like this. 60 degrees 15 minutes. 60 degrees 15 minutes. I converted the angle, Akshita, into minutes. In our calculator we have facility, right, to convert it to minutes. So I converted it to 60 degrees 15 minutes. So this theta value is going to be 60 degrees 15 minutes. So now this total angle from here to here, Akshita, from here to here, total angle will be 60 degrees 15 minutes plus 23 degrees. That's going to be 83 degrees 15 minutes. Okay, na? Now if you want the bearing of B with respect to A, simple, what you have to do is, I'm writing it here, bearing of B with respect to A will be 360 degrees minus 83 degrees 15 minutes. So we can calculate it. 360 degrees minus 83 degrees 15 minutes. We are getting the answer as 276 degrees 45 minutes. This is the bearing of B with respect to A. It might be a little confusing, but there is no complexity at all. We just have to find that angle and subtract from 360 to get the bearing of B. So this is about the last question, 12th one. If at all any doubt, please message me again, sir, I could not understand. Then you please write down the solution. Might be it is right. If at all any mistake comes, it might come in this value. If this is also right, excellent, very good. If still the doubt persists in your mind, we will discuss it in the next Saturday. Okay. So this is a very good question. Now I am going ahead, Akshita. We are going to discuss surface areas and volumes. So your textbook has given really good exercise on that. Areas of quadrilaterals is also given. Yeah, your textbook itself has given a good amount of exercises. Okay, let me follow textbook for the first part. There are very good number of questions in your textbook itself. So in your notebook, please put the heading as, if you want, uh, just leave some 1-2 pages, so that any incomplete is there in the previous chapter, we can complete it. Please put the heading as surface areas and volumes. So now, before going to this chapter, I think immediately you'll get in your mind, if at all I'm going to discuss about surface areas and volume, that means I'm going to learn about 3D figures. Sir, before learning 3D figures, it is a compulsory or must and should to be expert at 2D figures, because 3D figures are nothing but extension of the 2D figures. Very simple. Right now, you can take your writing pad. If you put 10 writing pads upon pad upon pad upon pad, you'll be getting a cuboid, right? So 3D figures are nothing but extensions of the 2D figures. We should be very strong at the 2D figures, so that your textbook has done perfect work in strengthening you about the 2D figures. So I will take it from that, and then when we go to the 3D figures, I will go to R.D. Sharma. Now, what you can do is, some things they have given. Okay, please put the heading as very small and very large units. This is very interesting. Your textbook has designed it very well for a student. Very small and large unit. Before this, anything else is there? Yeah, it is there, Akshita. Okay, I will discuss it that also. So much is there. Good. Really, your textbook is so excellent. Before going to this very small and large units, we need to know about metric prefixes. So you can put a different heading, metric prefixes. So in this metric prefixes, we are going to learn, the prefix which we are going to put before a unit. Let's say meter. So before meter we put kilometer. Before meter we put millimeter. Before meter we put centimeter. These are all called prefixes. So not only these are the three main things which we use in our day-to-day life, but other than them, there are plenty of prefixes which we use scientifically in our subjects. So let's learn about them also. Let's go in a different kind of interesting way. The first one, okay, before that, how to start it? Sir, when you are saying kilometer, what does that mean? Matlab 1000 meters, right? That means you are multiplying 1000 into 1 meter. So what does the prefix exactly does? It will give you a multiplying number, so that you can use that as a bigger unit and general unit. Now when we talk about kilometer, and what else? Kilometer, yeah, centimeter. Centimeter is nothing but 1 by 100th of a meter. So what is the multiplying number here? 1 by 100. And here what is the multiplying number? 1000. So this prefixes are nothing but multiplying numbers with basic unit. Fine. Now let's go with that. First one, you have a prefix called pico. Sir, not that prefixes, I have shown an example that we are using it for meter. You can also use these prefixes for gram. You can also use these prefixes for second. All the basic units like, gram, meter, what else, second, many things more are there. If we come to force, newtons, there are the different things. You can use prefixes for all the basic units. So first prefix is something pico. So pico matlab it is the multiplying factor is a 10 power minus 12 pico. Okay. Next one, you have nano car. Just for example, nano. Sir, nano you have n, n is connected to 9. Just remember, nano is very very small. 9 small matlab 10 power minus 9. Are you getting that? Okay, you might be really confused. What is the meaning of 10 power minus 9 and everything? If not understood, I will call you in the afternoon to know whether you really know about any number power negative. Sir, 10 power minus 12 matlab very simple, 1 by 10 power 12. 10 power minus 9 matlab 1 by 10 power 9. Like we write, for example, like we write centimeter, I told centimeter was 1 by 100 into meter, right? That's nothing but 10 power minus 2 meter. Okay. So this is the thing. Next, after nano comes micro oven. Micro is 10 power minus 6, nothing but 1 by 10 power 6. Fourth one, you will have milli matlab 1 by 1000, 10 power minus 3. So it is very important to remember these prefixes. Just right now itself you can put it in your brain. Micro 10 power minus 6, nano 9, car, small car 10 power minus 9, pico 10 power minus 12. Even there is much before pico also, there is something called Fermi. It's not given here. Yeah, Fermi is there, sir. Even much before pico, there is some other thing, a prefix called Fermi, which is 10 power minus 15. This kind of units, where do we use, sir, Fermi and pico in terms of atomic structure. In chemistry, there is a topic called atomic structure where you have to discuss the radius of an atom. There you will be getting the unit called Fermi. Okay. Now fourth one is milli. Next I am going to the next page. Fifth one, centi. 10 power minus 2 or 1 by 100. Now sixth one, deci. That's nothing but 10 power minus 1 by 10th. Okay. Till sixth one, all the prefixes are prefixes which reduce the value, because 1 by 100th, 1 by 1000 it's reducing. But now from 7th onwards you will have the units which will increase the value. Deca. Sir, there are also shortcut units for them. If at all you want to write it as, if you want to write picometer, if you don't write it as picometer always, you write it as PM, means picometer. If you want to write nanometer, you'll write it as NM, nanometer. If you want to write micrometer, it's not MM, it's not at all MM, because MM is used for millimeter. So micrometer, you write it as mu M. This is a Greek alphabet, micrometer. So like that, I'm just writing their shortcut names: nano, micro, millimeter M. Next, centimeter C, decimeter D. Okay. These are all unique names. You can use it, they are legal. Seventh one, deca. Deca is multiplying into 10. So multiplying factor is 10, or we can say 10 power 1, that is 10. So here what will be the signs are, it's not D, because D you have already given for deci. For deca you have to use DA. Okay. Next, let's go for 8th one, that is after deca you will have 10 square, hecta. Hecto. That is 10 square, 100. Like we say na, hectares of land something. So hectare, I don't know exactly, hectares will be coming under this. Okay, fine. Next, 9th one. After hecto comes, which you know very much famous, sir. 10 power 3000. What do we call it? Kilo. Okay. Next, 10th one. 10 power 9. 10 power minus 9 we call it as nano. Right? So here what do we call it? Giga. Call it giga. Next, 11th one. Some 10 power 12. 10 power minus 12 we call it pico. Here we call it as tera. Terabytes, gigabytes. In computer language we have it, right. So now we see the shortcut language. Hecto, H, kilo, K, giga, capital G, tera, capital T. Fine. So now these are the different prefixes which we used before all the things. So please note down. I'll give you 1 minute or 1.5 minute of time. 1 second. I'm not getting able to get that. Okay, fine. Next time, moving ahead. See, these are the units, prefixes. Now, before going to this, yeah, you know all this, I feel. Yeah, you know it. No need to teach about that. Your textbook is also given something about digital memory. Just a small thing. I'll teach that and I'll end the class about digital memory. I don't know why they have thought, but good to learn. Like now, we'll have something called kilobyte in our computer language. Kilobyte, KB, right? Kilobyte. How much it is going to be? 1000 bytes. Kilo means just before only we learn na. Kilo matlab 10 power 3, 1000. Okay. Next comes megabyte. Megabyte matlab mega is 10 power 6. Did I write it here? Oh, I forgot to write that. Sorry. Please, in one more point in between 9th and 10th. 9th and 10th, let's call it 9 star. Mega, it's represented with letter M, which is nothing but 10 power 6. So when you say megabytes, 10 power 6 bytes, or you can also call it as 1000 kilobytes. Okay, next comes gigabyte. So megabyte we call it MB, kilobyte we call it KB, gigabyte we call it GB. 10 power 9 bytes, or we can also call it as 1000 MB 1 GB. So yeah, next 1 terabyte we call it TB. Hard disk na we call hard disk 1 TB hard disk, 2 TB hard disks. Well, 1 terabyte is 1000 GB or 10 power 12 bytes, nothing but 1000 GB. This is about the digital memory which we are learning. So tomorrow I will go ahead in discussing the questions, and also we'll have small and big large units of length, distance and time. Okay, fine, then we will stop the class over here.